Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be looking at the I2C interface for Alpine Linux on Raspberry Pi. It uses the GPIO header, but it's a great way to integrate sensors into your next project. So let's get right into it. Alright, so what we're going to be doing here is we're going to actually be taking a look at this. And this is the SHT31D. It's an I2C sensor that does temperature and humidity. And we're going to be using it as our example today to be able to actually integrate it into the GPIO of the Raspberry Pi. In this particular case, I'm using the Raspberry Pi 3B+, but this actually works on all Raspberry Pis. It also works on other things like the Raspberry Pi Pico, things like that, and Arduino. But we're going to be focusing mainly on the Alpine Linux installation on Raspberry Pi. So I have 4 connections that are actually created here. And the 4 connections are a 3.3 volt connection, right? So if you could see it, it's on the second row there, but it connects to VIN of the actual SHT31. Next is we have our ground connection, right? And that's just going to provide, obviously, our other half of our power supply. And then we have 2 pins right here. So we have the SCL, and it's labeled SAA, but it's SDA. And those correlate to these 2 pins right here. And that's GPIO 2 and 3 on the Raspberry Pi is what we're going to be using. Now, there's a couple of setup steps that we actually have to do in order to be able to get this to run. And I've done a little bit of pre-work here, but I'll kind of take you through the steps that I had to go through in order to do that. So first thing we had to do was install Python 3 and also SM bus. So we did apk add Python 3 and then py3-SM bus. And it's already installed, but you did that anyway. The next thing that we have to do is actually install a pip package. And before I do that, we actually have to reboot this, and it's going to be a bit of an issue to try and get it to save, and I'll go through that in a second as well. But I want to modify the actual user CFG file in order to make sure that we're able to access our I2C bus. Pretty much, how do we turn it on? So if we were to try and go and edit our user CFG file, that lives on the root of our actual our memory card, SD memory card that we have inside of the Pi. So we obviously wouldn't be able to write to it if it's in a read-only state when it's booted. So we need to actually first mount our root drive as read-write. So the way that we do that is with mount-o remount rw /media/mmcblk 0p1. Now we can edit our user CFG file, and it's possible that it doesn't exist for you, but if you at least make it at this path, it will be able to read it normally. It's just a regular text file. You could also make it on another machine by just putting in the SD card in an SD card reader. But we're just going to edit it here. So we're going to use VI, which is Vim, to do this. So we're going to do /media/mmcblk 0p1, and then we're going to do user cfg.txt. When we go inside of there, I've already added this entry, so we're not going to have to reboot in this particular case. But after you edit anything here, you will have to reboot. And it's the second entry here, which is the dt param I2C _arm equals on. So dt param equals I2C dash arm or _arm equals on. And pretty much we can save that out. That's all we need. So now that we've had that, let's say we rebooted, okay? Now it has the I2C bus enabled, but we have to load a module in order for it to actually read. So to do that, and just for the record, if you did edit it here, I'll show you this really quick. if you wanted to put it back into a read-only state just for safety reasons, for keep protect it from yourself, you could do mount-o remount, ro /media /mmcblk0p1. And that will put it back in the original state you found it, so you can't modify that file anymore or anything else on the root drive. So back to the actual module that we have to load. In order to load it, we would just do mod probe and then I2C dev. And in this particular case, I already have it loaded, but we could try running it again. It doesn't give an error. And that will load it one time. So pretty much if you were to reboot it after this, right? So you've already rebooted it once after you've added it to your user CFG file, that entry. And then you restart, and now you type mod probe I2C -dev. It will stay working for the amount of time that you have your machine on. But as soon as you restart it, it's going to go away and you're going to have to type it again. And that's kind of annoying. So how do we make it persistent? So what we would do is we would do echo, and then we would echo that I2C -dev, and we would actually output that to a file. So it'd be /etc /modules.d, modulesload.d, and then we would call it whatever arbitrary thing we wanted to call it. In this case, I'm going to call it I2C.conf. So now, since it's in the ECC directory, it's going to automatically be added as part of LBU. So when we do LBU commit -d, it will save that, and now from now on, it will automatically load that module every time it boots. So what about that package? So there's another package that we need, which is a Python package. And in this particular case, it's not available as one in APK for actual Alpine Linux on any distribution that I've seen. And we're going to be using the Adafruit SHT31D library. And that includes a couple of other libraries, things like that. But in order to install it, we have to use pip3. And I'll show you when we actually do pip3, it's going to present an error. So the command for that is pip3 install. And in this case, I did have to install pip3. So I did apk add, I believe it's py3 pip. Well, I do know that it is that, but py3 pip, so I installed that, and that gives me access to pip, which is Python's package manager. It's kind of like APK, but just for Python. It also works on any OS that Python can be installed. So we have to add it, so we do pip install, and it's Adafruit, and this is really long, so be sure to check down in the comments. I'm going to create a gist on this, just so that way you can copy and paste instead of having to type it all out potentially, or at least have a better reference of it than watching the video back and forth. So it's going to be Adafruit-circuit Python -SHT31D. And when we hit enter on there, it's going to actually search for the package in the pip repositories, which are separate from the Alpine repositories. But it gives us this error, which is externally managed environment. Right? And what it's effectively saying is that because we have a lot of packages already available through APK, pip3 is not actually recommended to use on Python because it can potentially break when you reboot. It's not going to save any of that by default, and it's not going to reinstall any packages installed through pip every time it reboots. So there is a way to override this. And specifically, we're going to use this right here. So it's this flag, which is break system packages. They make it sound very scary intentionally. But in this particular case, that's our only option for getting this particular package. So I'm going to hit the up button here just to go back to this. And after the install command, I'm going to type -- break system packages with a space. And now we try it again. And what it's going to do is it's going to search through again, but then it's going to download a whole bunch of related files and libraries to be able to actually use that particular library. So just this actual error right at the bottom, if you can even read it, it's just talking about running it as root. Because we only have root on this, it doesn't actually matter, but if we did have other users, we'd want to run it as a non-privileged user. So just something to keep in mind if you set up your machine initially with other users and you want to be able to run and use these packages as part of that, make sure you run pip as that user. So now we have everything installed, but we want to try and make sure that this actually gets preserved. So we have to add it to LBU. So we have to do LBU add, and then we can just add the path where it actually installed it. And the place where it installed it was /user/lib/python. And if you hit tab, it will automatically complete, but it's actually specific per Python version. So in this case, we're running 3.11. So just keep that in mind. If you upgrade your Python, you will have to reinstall the packages, and you'll have to update your actual LBU in order to be able to reflect that. Now, there's a lot of files in here, so if I just tab twice, it goes straight off the screen. But those are default packages, default libraries, I should say. So what pip actually does is install it to the site packages directory. So if I just do tab, we see it automatically completes to packages. And if we tab into this, sorry, I hit tab twice, we see that it's a much shorter list. So it's everything, where's my prompt? So here to here. And specifically the things that we added were these Adafruit entries right here. And we want to be able to preserve that. So what we would actually do is pretty much add all of that. So we could just actually, if we wanted to, save everything in site packages, which would allow us to be able to add things to it in the future easily and remember it. It will save everything in there, things like that. And that may not be a bad idea, but obviously we installed some of these packages using the actual package, the APK package manager. So in our particular case, let's just do Adafruit, and we'll put a star because we want to include all of it. And that being said, there's the potential that we may be missing stuff, and I actually did try it and it still required me to install it. So I'm not entirely sure why it did that, but in our case, we can just do a star here as well. And although that's not best practice, it will definitely preserve everything that's inside of the site packages folder. So just something to keep in mind, and then we do LBU commit in order to save that out. Now what I've done is I've pre-written a script. Okay, so it's a Python script, so I'll just VI into it really quick. And it's very short. But what it has here, so I have the shebang at the top in order to actually tell it that we're using the Python interpreter when we run it from the command line. But we're going to import board, bus.io, Adafruit, SHT31D, time and date util. And the purpose of the script is actually to just output every second the time, the temperature in Celsius, and the relative humidity as a percentage. And that's it. And it just keeps outputting that to a file and logging it to a file every second. So down here, we see it initializes the I2C bus and tells it that we're going to be using the board.scl pin, board.sda pin. Then we initialize the Adafruit library, telling it that we're using that bus.io for, right, so the I2C up here, we're putting it down here in order to be able to actually use it. Then we tell it what output file we want to use for our time, temperature, and humidity. And then here we have our while loop that actually does it. So first thing we do is we get our temperature and humidity from our sensor. Then we create a timestamp, format it all, and actually create a data string. And we're also going to print it to the screen. So we'll do that here. And then we'll append to the end of a file right here. And just to make sure that it's not running too frequently, we'll sleep once per second here. So now that we've seen it, we understand it, let's quit out of this and let's actually run it. I have given this chmod permissions already, so I'm just going to be able to run it using the /. And let's see what broke. Name I2C is not defined. Let's go back into the file. This didn't happen during testing. So this right here, bus.io I2C, it's saying this is not defined. And that's part of SM bus. And it is possible that the way I tried to do it before with the LBU add may have actually broken it. Let's see. So there is a way that we can go about troubleshooting this. I'm gonna just try it once more. I don't think it's gonna work because, you know, nothing does it like that. So I'll just show you really quick. With pip3 or pip, you can also uninstall packages. And even though we have it added to LBU, it's obviously not going to affect its ability to be able to save it. But it will uninstall it, we can just reinstall it, and hopefully that just resolves our issue. Which then you'd obviously have to do the higher level folder in order to capture that. So I believe it's removed. If we want to just look at pip really quick, just going to do -- help. That didn't help anybody. All right, so we could do install, download, uninstall, freeze, blah, 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 blah. So we're going to use uninstall for this. So we'll do pip uninstall. And then pretty much the name of our package. So we're going to do Adafruit, CircuitPython, -shd31d. And it's going to ask us for that same flag again when I run this. I'll do it just for fun. Let's see what it does. There it is. So we're going to have to add that same flag, which is the -- break system packages. Let it do its thing. So now it removed it. It says it's not installed. That's not great. Otherwise, what I'm going to do is I put a typo. That's on me. SHT31D. Am I sure I want to remove it? And it actually shows us the path that it's currently installed. So in this particular case, we want yes. Successfully uninstalled it, so let's go ahead and reinstall it. I put the typo again. And let it reinstall, and then we'll be able to hopefully run our script. So let's try that now. And that's still saying that it's undefined. So there is a tool that's also installed as part of SM Bus and I2C tools in general. So if we actually do APK search I2C. We'll see there's a number of packages available to be able to do it. I2C tools is one of them. So if we do apk add I2C tools, we can make sure that we're actually running everything that we need in order to be able to do it. In this case, I already have it installed. So if we do I2C, tab twice, and do detect, or do dump, we can do detect. It says no I2C bus specified. If we do ls/dev, see if it is actually there. It may not be, and I may need to reboot again. But we do see I2C1 is there. So what we're going to do is do that, and then we'll do I2C-1. Says it doesn't match any bus present. So that is correct. So it's automatically creating the I2C-1. Had to read that really quick. So right here, you see the path that we just looked up in dev, right here. And then down here, it tells us the address ranges that it's going to probe. So we're going to make sure that our sensor is being detected successfully. And we do see it here on 44. So it is responding. And we can actually test that by disconnecting the power from it, right? So now it has no voltage input. If we run that again, it is still showing up. Let's see. Oh, maybe it wasn't detected. Maybe that's our host. So let's repower this. Try running it again. And it's actually not showing up. So your guess is as good as mine. We'll have to find out. So anyway, I'm going to reboot. And the reason being is that we touched a bunch of files. We also did the mod probe a second time. And I'm curious if I messed it up. First, I'm going to save my work and then just do a quick reboot. Best laid plans as it goes. So I did actually go through, I tested all of this, and of course this didn't happen during testing. So what are you going to do? You know, it's one of those things where no matter how much you prepare, there's always going to be an edge case that comes up that just kind of makes it a little bit of a mess. I was hoping this was actually going to be a 15 to 20 minute stream, but you know, this is what happens when we're doing it live. But I do prefer doing it live that way. If people do want to log in and ask questions, things like that, they can do so. And to be honest, it kind of shows that, you know, if you're having trouble doing things like this, you know, it's not a big deal. It's normal. Everybody goes through that type of thing in terms of when you first try and figure out which set of commands, everything else like that you need to use. You know, it's going to potentially not all play nice together in the sandbox. It still says I2C is not defined, and I'm curious if all of our related packages are installed and I forgot to write it down. Let's see. Right, because we have board, bus IO, Adafruit, time. So bus IO is from SMBus from Python 3. Let's make sure that's installed, or we can also try removing it and adding it back. And let's add it back. Oops, I want to run it. I2C device. If you look at this backtrace right here, so what it does is it goes from the first part, so when we're importing it, it then gives us a backtrace for how it actually got to this error. So we started by calling line 4, and then it went in and it found an error on line 34. And what it said is I2C device import I2C device. And then site packages Adafruit bus I2C device.py class I2C device on this line. And then down here, so maybe this isn't SM bus at all. This line down here said init self I2C address init probe bool true. But that's still on the Adafruit bus device. But it's referencing I2C device. So let's see what that is. Let's just do a quick search and make sure that we have our packages installed. We're going to do py3 dash and do greep, because there's a lot of packages there. And we'll do greep for I2C. See if anything comes up that we missed. Oh, I did add instead of search. And it came up with nothing, so we're not missing anything as far as that's concerned. But we may need to just search this. I'll show you how many packages there actually are. It's a lot of packages. So let's switch over to our other machine really quick so we can do some internet searches. And unfortunately this isn't, this is a Windows machine, but we can do a quick search on this. So let's do I2C Python I2C library. So this takes us to I2C device, is Python framework. I can go back here. I'll turn that off really quick just so you can see this and zoom in here. Will it pop out? Maybe? Okay. So it's a framework aimed at dealing with SM bus I2C device interaction patterns. So the question is, how do we get this? And we may need to actually just do another one. For some reason, I'm not entirely sure why it didn't install it the second time or stay installed. And it may be doing something in the background that is not particularly awesome. So let's switch back over here to our Raspberry Pi. Let's just try adding I2C device as through pip. So let's do pip install I2C device. And let's just see what it says. Same deal. I gotta do this flag every time. And it says it is downloading like it wasn't installed. So I'm not sure why it decided to just not install it. We saw that we had the SM bus package installed through py3, and it did work the first time around. So in fact, maybe it did actually break the packages, the system packages. So let's just try running it now, and we may actually be good to go. Oh, that looks great. No, it's not. So it still says that it can't find it. We could do a ground up install. Let me actually do that. I'm going to back up this particular file really quick. The ABK OVL file. And let's go ahead and do that. And okay. So now what we can do is we can do mount -o remount rw /media mmcblk0p1, and now we can do rm /media mmcblk0p1, and then in this particular case it's called GPIO APK OVL tar.gz. And now we reboot and it will be a clean installation as if we just did an installation, as if we just copied it to the USB. So let's give it a second here to boot up. We're gonna have to go back in and reinitialize it, and I'm gonna have to recopy over the actual file itself. We're not gonna retype it out. But let's see what we can do to actually make this fully functional. All right, so we're gonna do setup Alpine, US in this particular case. I'm still gonna call, let's call it I2C, just for fun. Just so we can differentiate versus the other one that we already had. We're gonna use DHCP for this, no wireless. Going through this very quickly. New password, we're gonna set something extremely secure. Okay, we're gonna do US Eastern, which is my time zone, no proxy server. NTP, we're gonna use Crony. It is gonna synchronize. Then it's gonna come here. I'm gonna enable community packages by hitting the C button, and then do 1 in order to use the first CDN for it. We're not gonna set up a separate user, we're gonna set up SSH, and then when it prompts if we want to allow root login, we're gonna do yes, because we only have our root user. No SSH key in this particular case, although for production, obviously you'd want to set one for that. We're not gonna do a disk install. mmcblk0p1 for both LBU and for APK. And we're done. So let's do LBU commit-d, save that here, and let's get everything else set up. I still have the actual user config.txt file in there. So technically it should already be ready to go with the I2C bus enabled. So we do need to enable our mod probe. We need to install our packages. So let's do our mod probe first. Okay, and if we ls/dev, we should see I2C is right there. So it is being detected appropriately. Next, I will add it later to obviously commit to LBU, but let's just make this run really quick. So let's do apk add Python 3 py3 smbus and py3 pip. It's going to install a whole bunch of packages really quick, including I2C tools, things like that. So that's installed. Now we need to install our Adafruit package. So we're going to do pip3, or just pip install because it's technically linked. We're going to put in our flag here, which is the break system packages. Adafruit circuit Python -sht31d, and we're going to let that install. And magically in the background, what I'm doing here is I am dumping in the file that we just had back on there. Just so that way we have it ready to go. Let me see. Perfect. Okay. So if we ls the local directory, we do see it present there. I may need to add permission, so we'll do chmod +x. And now it can be executed normally. So we do /sht31.py. Oh, and it came back with the same thing. Why did it work before? Is this the same one? No. Oh, this is our pi. So we're missing a package. So this one is RPi GPIO. So let's do apk add py3 RPi GPIO. Oh, that's good. I found that. And now it runs. We finally got there. See how quick that was? So pretty much what it's doing here, it's just, I'll actually stop it so we can just look at it. So right here is what it's actually outputting to the file. So here we have a date. Here we have the temperature in Celsius. Here we have the relative humidity. So if I start it again, and I actually blow on the sensor itself, right? So I'm blowing on this little tiny square right here. That right there is the actual sensor, and the reason it has the hole in the chip is because that's how it actually measures the relative humidity, everything else like that. So I'm just going to blow on it really quick. See how the humidity rose? Temperature, I don't know that it got too hot there. Might be easier if I did this. So you really see that the numbers jumped there when I actually just breathed on it, you know? So it is measuring. It does have a holdover time for things like temperature, because obviously it has its own thermal mass to compete with. You know, it's not that much colder than I am, so at the end of the day, it takes a second for it to pop up there. But we do see it popped up to 28 and then went back down. So it is doing what we expect. But let's say we want to modify this a little bit, and let's actually make it show it in Fahrenheit as well for people in the US. Because that works for everybody else in the world with Celsius. And it is a very large floating point number, so you could round it, things like that as well. And maybe we'll do that, but let's just VI the file. So we're going to come in here, we're going to edit it. And pretty much what we want to do is we want to change our temperature and humidity settings here and add a few additional processes before we output it. All right, we're going to do 4 spaces. And in this particular case, it's a very simple equation in order to be able to do it. We're just going to set it back to itself. So we're going to do temperature. And we don't have to do humidity because obviously humidity is just a percentage. It's universal everywhere. So we're going to do temperature is temperature, right, which came out Celsius. We're going to times it by 9/5. So it's by a fraction, which is 1.8. And then we're going to add 32 to it. And that's it. That's right, Nola. All right, so we save that out. And when we rerun it, now we see that it's in Fahrenheit, right? It looks the same format, everything else like that. But that is obviously, you know, it's only going to be useful for some people. So that's how that goes. So something we can also do is just take a look at our file itself. So if we could just go back in and look, we did save it out to this output file right here, which should be in the local directory. So if we ls this directory, we do see that it is there. So if we tail it, well, we'll just tail it because it's not running. If we did -F, we would see it pop up as it was actually running if it was running in the background. We do see it's just adding the same way it's adding to the console right there. And if we VI into it, we can scroll all the way through here so we see our initial readings, everything else like that. And because we have timestamps associated with it, we could potentially graph it. You know, obviously if we have a unit conversion change, you know, sorry, if we have a unit conversion change starting right here, where above it is C, below it is F, you know, that obviously wouldn't graph very well. So you got to choose one number standard, one particular temperature standard as far as trying to graph it. But it's a good way to create a data logger. You know, maybe for temperature and humidity, you wouldn't want it to be every second. You'd want it to be every minute, things like that. That might provide more useful data to be able to integrate into your project to track, you know, how the environment around you is actually going, you know, how things are actually going outside or inside. One thing I will mention just about this sensor, if you are going to try and create like a weather station, for example, this cannot get rained on directly. It only measures relative humidity, not whether water is there or not. You know, it's not a moisture sensor. So something to keep in mind is that it should always be placed underneath some kind of covering, so that way any water that would hit it is deflected away. And you don't want it obviously to be pointed down on something that can splash back up. So it's just something to keep in mind that inside it works great. You don't have to protect it at all, unless of course you're prone to spilling things on it. But outside you have to protect it, and there's a lot of precedented kind of tutorials and guides on how to build enclosures to be able to support things like that. But because it's doing temperature, you obviously don't want it to be in direct sunlight, and because it's doing relative humidity, which is humidity suspended in the air, you want to make sure it's not getting directly wet, or it will also, even if it does survive, skew your readings. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.